Good day guys, being here. Today let's continue this exercise. So yesterday we modeled this part. So today we're going to, so first we're going to adjust this pattern by, what do we call this, pattern grids, and then apply this, and then eventually we're going to create something like this. Okay, so first, so I'm going to just so actually let me just go search hex, because I did one, so I'm going to use this one. So see this one, I did this one previously. So the idea is to use this hexagon pattern in Revit, but because the pattern, so I'm going to create a new one. Okay, so new family, we can use pattern based, curtain panel pattern based, and select this grid and then change this to the hexagon shape, or sorry, hexagon pattern. Okay, so this is a pattern we're going to use because we're going to place this one onto these reference line or adaptive points. But because, see this one, this is not a perfect hexagon shape, so we need to adjust this one first. So let me just do a screenshot. Okay, so what we're going to do is we're going to, so see this point 4 and 5, I'm not sure what this number is, but we need to offset, create a point here, another point here, and a point here, a point here, a point here, and a point here. So now, and with the some adjustment of the, so let's call this x and y. So this is the x, y, with some adjustment of the x and y, the value of the xy, so we can create a perfect hexagon. Okay, so in this perfect hexagon, we need to, so hang on, let me think. So what we needed to do is we needed to work out what this one needs to be. Okay, so this one equals this one, and also equals this one. So maybe let's call it, we already have x and y, so let's call it maybe n. Okay, so what we can do is, so if I draw a triangular shape here, so this, because it's a perfect hexagon, so this angle will be 120 degree, which means this angle is 60 degree. Okay, so and this is, so this is y, right? So this is y, so these are all x. So in this one, this is x. Okay, so this offset and this offset, this is n as well. So x minus 2 times n, which is this one, in this triangular shape, this one's, if this one's 1 and this one is square root 3. Okay, so so equals, so the minus 2 equals equals y, which is 3 square times x, so times x3. Yeah, I think this is it, because y in this triangular shape, y equals 3 square root 3 times this one, and oh hang on, and this one is sorry, I'm a little 3 times equals, oh hang on, not right, times, so times square, if we do this, minus 2 times square 3 equals y. Equals y. So this is the relationship between x and y. Okay, so And also we need another one. We need another formula because we still need to work out what the n is. So okay. So once again, let's find it. So x. So this is x, right? So plus this is n and n. X plus n and n. X plus 2 times n equals this one. So because this is a perfect hexagon, so equals this one, and this one, because in this one equals because this is 60 degree, equals 2 times this one, 2 times this, so equals 2 times x minus 2 times n. So this is another formula we can use. So so from this one we can work out x plus 2n equals 2x minus 4n, and move this x to here, x equals, move this to here, 6n. So x, this n equals x divided by 6. Okay, so now we can put this one in here. So x minus x divided by 3 times square root 3 equals y. So I move this to here, so it will be 3 square root 3 times y equals this 3. So let's go here, 3 2/3 of x equals 3 square root 3 y, get rid of 3, get rid of 3, x equals, so divide by 2 is 2y. So this is what we can use to adjust the pattern to achieve this perfect hexagon. Okay, so now we have everything we need, right? So we need this one to adjust the offset of this point, and we need this one for the scale, for the scale of x and y. Okay, so now let's go back here. So I'll just quickly place a point, draw on work plan, set work plan, pick the vertical point, place one point, another one here, another one here, another one here, another one here, and the last one. Okay, so select this point, so maybe it's easier if I select all these points and HH. Okay, so now we can select, use drag, select, so it's easier. So this need to go here, so I'll just create a new parameter, so I'll call it n. Okay, so and instance, instance, hang on, should be I'll use type for now. So if okay, so we already have those points. Okay, so this one need to go there, so I'll call it n negative. Okay, so and okay, go to family types, and n, where is it, equals negative n. Okay, so once again this one, okay, n, and this one is n, and this one go that way, and negative, and this one should be positive, so it's n. Okay, so now we have this, and then another thing we need to do is, so we can't let me check, no, not here, shared. Okay, I'm not quite sure about this one. Maybe I'll just leave it as a shared parameter. So we can roughly set this one for now. So maybe I'll just change one x. So let me check this one. Oh, this is x. Okay, so this, and then this is y. So x equals k. So maybe we set y as 1 meter, so we can use this one. So it should be the same. So you can do you can convert the formula. So this one will be as equals, we just need to equals sqrt bracket 3 divided by 2 and times 1 meter. Okay, so the, oh sorry, wrong one, so this must be wrong. And let's do it again, equals sqrt bracket 3, okay, divided by 2. Yeah, looks about right. We don't need that bracket there. Divided by 2 and the times this times 1 meter. Oh, something's not right. Hang on, let me just check. Square root of 3 equals sqrt 3. Maybe let's just divide by 2. Maybe add a bracket. So I'm not sure why, but I don't think it should be different. Divide by 2 and times 1 meter. Oh, something's not right. This is annoying. So let's have a look. So x equals square root divided by 2 times x. Yeah, that's correct. Anyway, equals. Oh, sorry, change it. Oh, change this to 1 meter and equals 1 meter. Okay, so let's put 1 meter in the front times sqrt 3, because sqrt 3 is 1.732, and yeah, this should be right, and divided by 2 and should give us, oh interesting, yeah, this one should be correct. Okay, anyway, so now let's have a look. N equals x divided by 6, because in this grids x is x, hang on, which one's x? X, okay. X is 766, so we can use the x, so n for n, so equals, oh no, we don't need the equal, 766 divided by 6. Okay, so this will be, and then this will give us a perfect hexagon if we connect. So just ignore this. Let me just HH and see this. So if I connect these, maybe we don't need to connect all, but just roughly show you. So if we connect all these points, and we will have a perfect hexagon shape. So if I click on top, you can see, yeah, so perfect. And for this exercise, we don't need the top part, we only need 1, 2, 3, because when these families being placed in a pattern divided surface or a mass, so it will repeat. So you can imagine another 1, 2, 3, another 1, 2, 2, 3, another 1, 2, 3. So doing only half will avoid overlapping. Okay, so now we have this one perfect. So now we can go back here and load this into what's the family name? Family 2. Okay, so load this into family 2. Okay, so now we can place it. Yeah, it's huge, but we can somehow adjust this a little bit. Okay, so I maybe just put in 100, apply, and oh, that's very skinny in the middle. That's fine. So let's just start from, let's do it. Okay, so I'll use SE to snap endpoint, and SE again to snap on this point. Okay, so it looks like something's not right. Okay, so this is okay, so this is crazy. Maybe let me Control Z, maybe go back in this family and just reduce the value of this one a little bit. So to do this, we just need to move this point back to Okay, looks like we have issue here. So this family is not perfectly built. Okay, this is hard. So let me change this one first. 100. It works okay. And let me move this point. Yeah, it looks like we have some issue here. So I will just pause it here. I'll see if I can fix it, or at least I figure out how to fix it. Okay. Okay, I think I find out what's going on here. So there are actually two problems here. So one is if I HH to hide the solid. So when I create this one, so it should be I should use a place on face, but I think when I create this one, I use draw on work plan. So which means you can see I can move it away from this. So this will will break this family. So this line has to be snapped onto this reference line. So we can fix it by select the point and you pick new host. Make sure you draw on a place on face and place onto this line again. And select this line point. Pick new host and place onto this. So this will keep this line onto. You can see I can't move it away from this line. So now, and also another thing, so we need to do, so in order to adjust this family properly, so we need to check this. And okay, so now we should be able to adjust the family by just drag this point. Okay, so let me just type HR to show this. So, and now let's load this into the family 2 and override and create component. So it has snap to end, snap to onto the other end. Okay, so it looks like we still have some issue. Anyway, so that's fine. We can try to fix it. But I'll try this one. Still doesn't work. That's fine. Okay, let's let me think. We should probably try this again. So if I drag this one, yeah, it works. Okay, so it looks like we these void, they are not working anymore. So where's the point? So that's fine. We can fix it later. So let's just delete them. So even all the Control Z. Let's delete these two void for now, because I think it lose these. They lose the point on the surface, but let's make this work first. Okay, so I just want to load this into family 2, overwrite, create it onto this, onto yeah, it works here but not here. Yeah, it's interesting. Okay, so it's almost there. Yeah, it works. Okay, so it's improvement, but still not perfect, right? So, but don't give up. Let's just continue try. Okay, so place another one here, another one. Yeah, it works again. Another one here, another one here. Okay, so it looks like yeah, it's very weird. It's all odd. I don't know. Maybe let's try this. See if we can just change this one to a different setting. Not quite sure, but we can always try. Override. Oh. Okay, it breaks it. Let's go back. Let's Control Z. Okay, so change it back to instance, but we can still go trying to figure out how to place them properly. So actually, what I'm going to do is I'll just go to the top view of this, and I'll just without using any trying to tab or select, I try to just pick it here, pick on the first point I can snap onto, and here, and this one, and this one, and this one, and this one. Okay, so now it looks like this one and this one's oh, they're all different. Okay, this is crazy. Anyway, even they rotate, that's fine, we can always manually adjust, but let's just go back and fix the where is it? Sorry, where's my family? Here. Yeah, so let's fix the void. So I just quickly, you should still remember, so let me just scale it properly. So yeah, that's better, so we can see all the parameters. So point, draw on surface, and try to snap onto here. So this point, right? So and just create something, create a void just big enough, and cut. And so this one should go the other way. So 0, I'll just type in 1 meter. That should be enough to cut here. So cut solid void, and okay, so quickly let's do the other side. Yeah, I think this is the issue when we directly place it here, probably that will create some issue. Maybe I type SE, so it's on this line instead. Okay, if we place there and when it's being cut by the void, and then maybe it get lost. So that's my guess. Okay, just draw another one, void. Oh, good. So now let's try again. So hopefully this time nothing broken. Yeah, great. Finally. Okay, so now let's load this into that hexagon shape. At least the shape is correct, and then we need to, so first let's select these. I'll see if I can reduce that, so maybe 200. So that's for the, yeah, so that's good, because this is a shared parameter, so we will be able to adjust this in the project or in conceptual mass. So let's just leave it for now, and we need to rotate it. How? Maybe we can do this. Go to family types. So select this solid. So these are the angle we can use. So I'm going to create a 2 parameter. So A1 and maybe instance, because we're going to use different value, right? So A2 instance, okay, load this back into family 2, overwrite, and okay. So okay, looks like there's something's broken again. Yeah, that's fine. Let's just ignore it for now. So this one. So how can I rotate it by 180 degrees? So type in 0 and 180. Okay, good. So this one's already correct, and this one just need to be rotated by 90 degrees. So let's guess 90 to 7. No. Should be 27. Hang on. Negative 90 to positive 90. How about that? Yeah. Okay. So looks like the one of here at least, so this void is not correct, so we still need to check. So maybe maybe we can just rotate this here, so to test, see why is this happening. Maybe I'll just use 90 to 270. Apply. Okay. So this void is correct. This one's not. These are not. So this is quite annoying. So okay, so let's fix it. So this one's correct. So this is a point. Let me just check. Yeah, it's on this edge. So where's this point? It's gone. Or is it there? Let's just place another point, draw on face. Okay, so just double check, draw on face, place onto this edge, and drag to this end, reference rectangle, draw on world plan, set world plan, pick this one, and draw a reference line, create a void, and the other side. Okay, so this is good. So 1 and 2. Looks like this one's not right, so let's delete it. Okay, so this one's also not right, delete it. And this one's not right, so yeah. Okay, so now let's try this. Draw on face and place it on this reference line, on this edge, drag it, reference rectangle, set world plan, and do another one, void. All good. Yeah, all good. And this one, so another one, and draw on surface, drag it to here, reference line, and another, rectangle, and a void, and the other side. Oh, good. So okay, so let's try this one. Overwrite. Yay. Finally, see, perfect. And then we can apply this into a conceptual mess. And okay, so that's great. So that's 12 o'clock. Let's create a conceptual mass. Okay, so it will be a, so let's create it, I just draw a point, copy, and spline. So go to 3D view, I'll just make it a reference line, go to the front view, I'll copy it up, so roughly here, copy another one roughly here. So I'm going to create a surface, create a form, and maybe I'll just move the middle one a little bit. Okay, so perfect. And then I'll just place some point on the midpoint of each reference line. I'll just make them point driving. Okay, so and then I'll just use my keyboard again to create a curve. So now this is quite nice surface. I'm going to use divided surface, and I'm going to use a hexagon. So now we're going to do some adjustment to, so first we need to change to fixed distance. Okay, and then we need to, so these, one of them is x and the other one is y. So because we have this one, so x equals sqrt 3 divided by 2 times y. So we are going to maybe hang on, which one's y? I'm not sure. Let me just do this. Okay, so this is the horizontal one, which is x. Okay, so I'm going to call this one. I'll create a parameter. So this one will be y. Okay, so let's call it y, and it will be instance of type. Doesn't matter. Okay, and then create another one is x and type and okay. So now go to family types. I'm going to use that formula. So which this one. So in x, so it's sqrt 3 divided by 2 times y. Okay, so this will give us a relationship between x and y to keep those these hexagon pattern to suit the pattern we did. Okay, so now I'm going to find my half hexagon, which is this one, load into this, which is the conceptual mass. Okay, so now this might take some time, so I'll just apply it and I'll pause the video, so save some time. Okay, so this is what we get. It's okay, don't give up. So at least some of these families are correct. Looks about right, but some of them not quite right. So there's some setting we need to just to check. So one is, so if you select one half hexagon family, this offset, so because previously we get this one offset need to be 1/6 of x, which in this divided surface it's this number. So maybe we try to change that and see what happens. So it's 10920 1090. Oh, sorry, 10. So let's go edit type. Just type here equals 10920.5 divided by 6 and apply. And I'm just going to pause. Okay, I think it's closer. Okay, so yeah, I think we still have some issue with all the void. I think probably it's not a good idea to use this method we use, because especially when we rotate, the point just get lost. Okay, so it's not but first we just need to try to fix this. So the next one, so we're going to set try is x is the gap, but the radius of at this this point. So maybe we change it to be bigger, because the whole thing is like 10 meter. So this is two things. So maybe I'll make it 2 meter and click OK, and then I'll pause again. Okay, now it's even better, but still, yeah, the void, the issue, and we need to flip this to the other side. So what we can do is we have this component flip. Check this box, and I need to pause again. Okay, so it's better, but because the void is not working, we don't have those perfect line between them. So I think that's maybe let's stop it here, because it's quite long. I think it's more than half an hour. So maybe we will fix this in next video. How about that? Okay, so don't worry about the family. Once we finish this one, I will upload the family for you so you can have a play. Okay, so thank you. I'll see you tomorrow. Thank you. Bye. Okay, sorry, I have to add this. So actually, I just had a look, and it turns out it's working. So the reason why it looks like it's not working is because the scale of this model. So when we model this, the scale is quite small, and in this pattern-based family, it's huge. So, and the void, this is the profile of the void, and when we create them, it's too small. So we just need to adjust this shape, size of this, and also the depth of the void. So let me just try to select the solid, and then we can pick the void. So if we increase the depth of this void, so we can fix this. So which means this method works. Okay, so it's just need to make sure this void is big enough and deep enough. So I'll just quickly fix this and show you the final result. I believe we can fix this. So let's try to select the void and increase the depths. So, and the last one, so this is the profiles. Okay, so big enough, and tab, and deep enough. Okay, so this is it. Now if I load this into the final one and overwrite, and this should fix the problem, and hopefully we can finish this one, so I don't need to see it again. I spent like more than 10 hours on this one already. So this is this is the third one I did. So the first one I did, I'm not very happy. It works, but I'm not very happy to with the shape, and it's not perfect. The second one I tried to model it last night, and yeah, eventually this it works, but still today I tried to redo it again. Oh, this is crazy. Oh, what's going on here? I think almost good. So except this, I'm not sure why. Maybe we can adjust this a little bit and see what happens to them. Okay, so if I change this to 1.8, so but other than these, it looks like all these are perfect, right? So even with a little gap between them, so this will create if we render, so with this gap it will make it more realistic. And also I think the shape, the curve at this point is good. It's better than the first one I did. And the only thing about this family is because it's a shared, we can't build the parameter to we can't set the offset of those points to automatically match the pattern, match the size of the grid. So that's the only thing. We can just redo the pattern-based family, and then it works perfect. We can I'm not sure, I'm not 100% sure, but it's possible we redo we change, not redo, but uncheck the shared parameter and then delete this pattern-based family in here, and then reload that pattern-based family, so we can somehow build that link that's offset to this X and Y. So we don't need to, every time we change the pattern, we change the grid, we need to adjust the offset to be 1/6 of X. So, and other than that, it's all good. Yeah, I'm very happy with the result. Hopefully, yeah, you learned something with me. Okay, so and I will upload this family so you can have a look. Please do not just download family and use watch videos, and I believe you will learn more than just use family. That's it for tonight. If you have any questions, please let me know. I will see you tomorrow maybe. Bye.